Hello and welcome to C++ 102, Week 3. I'm going to be here. My name is Nelson, and so will Mr. Gavin.
Hello, Mr.
Hello.
People. Messes People.
Messes people? Is that the gender-neutral term, or I don't know.
Plural of Mr. is messes.
Really?
Anyway, yes.
Huh. Okay, so today this should be a fairly short class. We have some fun stuff to go over, a little bit of code to write, so I wanted to kind of open up the first part of the class, maybe, the first 30 minutes of class, as sort of an open office hours for people to ask questions about the homework, maybe some bits of code that they didn't quite understand. Obviously, if people don't have questions within the next few minutes, we're just going to go on with the class per usual, but otherwise, ask questions. A C++ is a D. I thought that was a funny joke, but nobody laughed.
And I think we can weld those two things into one. You misassessed the hilarity.
Oh, indeed. Well, so I'm going to go ahead and fire up my VM, which happens to be already fired up. And we're going to wait for...
Are you not seeing any questions either? Because I'm not.
I don't see any questions. I think everybody was good on homework. I'm making that assumption. The homework actually will be extended by a week, by the way, because of the video only becoming available today. Sorry about
today.
That. Yeah, the thunderstorms threw my entire schedule off, and it got lost in the pipeline of my recorded videos. Like I was uploading all the other videos that I did this week, and those have been made available the day after in each case, except for, well, the one that got kind of forgotten about. Can I go over the tic-tac-toe algorithm? Sure. I mean, we did actually, that is something we did last week, though.
We spent quite a considerable amount of time.
Yeah, I can quickly just go over the basic algorithm itself.
Was there a specific part of it you're having problems with, though?
Yeah. Okay, if title to enter can enter entity return, entity is undefined. Well, I'm going to be assuming that you are looking at this code right here. And I want to point out, if not title to enter can enter, entity is undefined. Well, if entity is undefined, that means it doesn't... I mean, I'm not trying to be, mean here, but if it's not defined, that means it isn't defined, which means that you most likely have a spelling error in your parameter list. Now, you'll notice that on line 35, I have a parameter list that takes in two parameters, an entity reference called entity, as well as a position called pose. Pause. So could you quickly just look at that for a little bit, see if that could be the issue? It's most likely a spelling issue. See, if I were to misspell it, this would replicate that error, because now you notice that when I try to build, it's going to say, well, in this case it says undeclared identifier, but I'm assuming that you are on a different compiler for that error. That's it, looked at it for hours. That happens a lot. I have...
Strange, I never find that.
For you? Oh, yeah. Just in general. Spelling errors are the most common mistakes you will make in programming, which is why, one of the reasons why I love statically typed languages with compilers, because when you're working with a dynamic or more dynamic language, or a language that's dynamically either JITted or compiled at runtime, you don't find these errors until the code actually executes that particular piece of code. So for example, in JavaScript, you wouldn't get an error until you tried to run that bit of code. I like thinking about a compiler as just the first set of automated tests. And I know they're not really, it's not an automated test in the traditional sense, but I feel that it does statically typed languages really do allow you to see problems significantly sooner than if you're working with a language that was not compiled. So yeah, I've spent many hours, probably aggregated into days, working on spelling mistakes. On the homework, I was getting an error as if I was looking into the index of a vector was not there. I got it working with tiles resize width times height and the level class initializer. It worked, but I didn't know if that was supposed to be there. Is that correct? Well, yes and no. Now, what he's saying is that what he did was, instead of having in the initialization list a tiles instantiated with a default size of width times height, he had something that looked like this. Tiles resize width times height. Both of these will accomplish pretty much the same thing. However, in the case where the behavior you want is accessible via a constructor, I would highly recommend using the initialization list to represent that logic as opposed to using it inside the constructor itself.
And that's about optimization in terms of the amount of work it's doing to get to the same point, presumably.
Right. Well, almost always, yes. I don't know if it probably is a little bit faster in this case because I don't know how much the default constructor for the vector uses, but that's really irrelevant. The fact is, if you can sidestep instantiating a vector and then resizing it by just instantiating it with the size, that's always going to be a little bit faster, and it's going to be more consistent with the rest of the things that you have, especially in cases where it's required that you use the initialization list. We talked about that before with constants, references, and types that do not have default constructors. So yeah, you should always use...
Did you, we never got any word back about tic-tac-toe from Dave.
Oh yeah.
And
he said in
BuzzNet
that he was going to look at the video.
Oh, okay. Can you please, if you want us to, if you're dealing with us rather than each other, could you put it in the webinar, please, so that because we tick them off as they go.
Yeah.
Thank you.
Okay, Shannon, I have no idea. Could we switch over to your screen? See, one of the issues with C++ is errors that you get in C++ are generally very far away from the thing that's actually causing the error, as we've seen many, many times. All right, so I'm going to go ahead and pull up your screen and take a look.
I still can't... I've never come across another program, I think for years, where the scroll wheel works this way round. Compared with webinar. If you go into the webinar questions panel and just scroll wheel, it's backwards.
Shannon, you're going to have to accept the do... Oh, it is backwards. You're going to have to accept the screen sharing. There's a button. There you go. Alrighty, so let's see here. Could you open up your error list, please? Go to View Error List, because that's generally a lot nicer to look at than the output window. Alright, and then if you click on errors, let's see. Now, generally speaking, when I deal with errors like this, where I see a lot of errors in header files that I have not written, what I'll do first is I'll scroll through the error list and find a header file or a CPP file that's actually a part of the project that you're working on. So if you scroll up, is there any error that's from a file that you've actually written? Because that's the first place to look. Well, that's in...
It doesn't look like it. They're all in objdl.h.
Yeah, if you scroll down, maybe.
Oh, well, there's a syntax error there's a parenthesis error being listed.
Right, but
Got
that's...
to be from...
Yeah, that has to be from something else, though, because if you look at it, it's from the obj.h.
And expected a semicolon as well.
So if you scroll down a little bit... Okay, so none of this is from your code. The next step to go ahead and close out of the error list. Do a... the next way to debug an error like this... And, of course, I could just scroll through all of your code, but I'm just trying to show, like, kind of a way to, a sort of process that you can go through to find errors like this. Now, open up the output, maybe make it a little bit bigger. 106 error. I suck. What?
It got stuck at level.cpp.
Yeah, it got stuck
according to the output window.
Let me see. It failed on. If you scroll up a little bit, look at what CPP file is trying to compile. Okay, so it got stuck at main and level.
Position and level.
No, main. There's a main after position.
Oh yeah. Sorry.
Okay, so you most likely have a error in code immediately preceding an include file. So jump out of this. The first step would be to scroll to maybe the top of level.cpp, because these errors are happening somewhere before you include something. Okay, so jump into level.h. That's the next step.
Hang on.
Huh?
If you go back to where you were, level.cpp, it's I think it's an angle bracket quotation problem. Because you've got windows.h in angle brackets and level.h in quotes.
Yeah, level.h should be in quotes. It denote that it's a local file, whereas the angle brackets denote that it's a library file.
Yeah, what I'm saying is the Windows one.
Yeah, that's a library file. So that's actually going to not be included, right, if without the angles. You're going to need...
So that was right, sorry.
Yeah, windows.h should be in angle brackets.
What's the name? Shannon. If I'm saying something, it's most likely that I'm asking Nelson whether that's the answer, unless it's a spelling issue. I thought.
Okay, so
Wrong.
Jump in. Yeah, just try level.h now. Maybe there's a syntax error somewhere in level.h. Missing. Just scan through for missing semicolons. That looks all good. Try position.h. XY. That looks all good. Yeah, I would just go through what Roland Stone said. Just quickly jump through all the H files one by one. It's most likely an error in one of the H files that's included by both level and main. That looks good. That looks good. Wow. So that's all the H files, isn't it?
Collide's not does collide not take those trailing equals? I can't remember.
Yeah, collide will need a equals 0. However, that will not cause the error that you have. But it should need it should be an abstract method. But after you did that, try this. Hit Control-Shift-S to save all your files. Or File Save All. Now go to Build, Clean Solution, and then Rebuild. See what happens. I see you probably have already done this. Okay, really does not like main. Okay, so if you jump into main.cpp, let's see here, and scroll up. Because of where the H file is, I'm assuming that the syntax error is happening somewhere before including windows.h, which is not possible in this case. Wow. Well, this is interesting. Could you go ahead and give me a mouse control real fast? I just want to flip through all the .h files and all the CPP files really quickly. There should be a thingy up there that you can click on. There we go. Alright, and then just because I want to keep track of what I've already looked at, I'm going to close out everything and then open up every H file first. I know we already went through these, but there has to be an error somewhere. Then I'm going to open up all the CPP files and I'm just going to scroll through, look for the most common mistakes that would cause an H file.
Can you move the
yeah.
output window off to one side, please?
Okay, so it's not in main. It's not in position. And when I say it's not, I mean it's most likely not. It can't be any of this code. This would be a completely different error if it were. Looks like you have some indentation going on right there, but that doesn't matter. It should work anyway. ITILE, identity, position, vector, no missing semis. Include identity, no missing semis. No missing semis. No missing semis. Okay, so I'm going to go ahead and dig through the output window a little bit more. So, jumping into this, although this can't be where the problem is from, but it's saying that there's syntax error, identifier, RPC.
Is there literally no way to... There isn't a stack trace at all?
No. So what's that? That is the next line over. It's saying that, well, it can't find this RPC out X count part thing. The next step is
Google. Could you go back to where you said that there's an indentation oddity that shouldn't affect it?
Ooh, it looks like this could be a known issue. Yeah, this can't affect it. I traced through all the things in my head, and I mean, if you just take a look at it, you should, unless I missed something.
No, yeah, I didn't get.
That shouldn't have a problem. Okay, it looks like this is a known issue. Working with the Windows 7 SDK. What do we have? Blah 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 blah. Problems with physics. Move the Win SDK directory to the top of... Ooh, do you have anything DirectX related installed on your computer? Like the DirectX SDK or something? There's a missing bracket on set character. Oh, no? Oh, right. Looks like there is, actually. Right there. Alright, while that's trying to build, let me dig through some... It's really not wanting to build. Ooh. I actually have a new trick to show people. If you... So this should be a fun experience for everybody. I think I know what the issue is, but there's a awesome output thing. So, like Gavin was talking about a stack trace for the includes. What you can do is you can jump into the project settings and open up the where are you? Command line, and pass in show includes. So that's why can't I type? I really can't type. There. Now, if you pass in /show includes and do a build, it will give you a sort of stack trace-like thing for your H files that are included. So, as you see right now, that's showing sort of stack trace of all of the H files, which, yeah, that's... See, this is why it takes a year and a half.
Yeah.
To,
but presumably also this is even slower, because it's actually got to deal with printing these back as well. Presumably that's why it's turned off by default.
Yeah. Okay, so it's saying that by doing this, what you can do is you can look through the different things that included this. So that was included by Object Base, which was included by OLE2. And what I'm looking for is that. So it looks like somehow there's some sort of conflict with an older version of the DirectX SDK. And it appears that the solution is, from what I'm reading, is to change the order in which the H files get included. So to do that, this is actually going to be obnoxious, because you'll notice that if people who, by the way, when you do a #include with the angle brackets, what happens is the compiler looks at the include directories. Those settings used to be available for you at somewhere. Show me the window. There we go.
That was the worst Cuba Gooding impression I've ever heard.
Yeah, there's something funky going on right now. Those used to be under, I believe, Project and Solutions C++ directories. However, this has now been disabled. It's now a property sheet that's added to projects. So to find the include directories, you have to right-click on the project, go to Properties, jump down into your VC++ directories, jump into include directories, edit that, and you have this. And here's the problem right there. Because that is before the Windows SDK includes, there's a conflict and the wrong header file is being imported. So I actually can't remember how to
just
change the defaults.
Is it the arrows by any chance at the top?
No, there's two sections of this.
Or a folder.
That's for your own custom include directories. This is for the project defaults. And I've actually never edited the project defaults in Visual Studio 2010. So let me go ahead and do a quick search on how to do that. Include directories, project defaults, Visual Studio 2010. Settings move to a property sheet. And the property sheet is available in a place I do not know. If you open the Property Manager view to see the property sheets associated with your project, you'll see that one of the property sheets named Microsoft CPP Win32 Users. This property sheet is actually stored in Local App Data. In Local App Data Microsoft Visual Studio 10.0. Using the property editor and the property sheet, you can see they're able to make edits directly in this file, since all project by default. Okay, so how do I get there?
Wouldn't it, it might be, I'm just, you're on someone else's computer at the moment.
Yeah, I don't want to go digging around somebody else's file system.
Yeah, just,
but I know that there's a way to get Visual C++ 2010 property sheets. Tell me where you can get this information. I don't want that. I don't want that. Okay, it looks like you are going to have to dig into... from the view menu, select property pages. Okay, so let's see this. In the view, apparently you can go to a option called property pages, not property manager.
It was, yeah, it's entitled property pages in the window that's open.
Oh, right. Well, let's dig around this then. I wonder if you go to Configuration Manager. Or you're going to have to, I think you're going to have to select the project in your Solution Explorer. No. Okay, so yeah, those are, that's going to open up that again. I wonder if you jump into these Configuration Manager, what options you get. The Configuration Manager button on the doohickey thing. The button on the top right. Nope, that's just your normal build configuration manager. Yay, this is fun.
Are you recording all this?
Yeah, it's a it's a good sort.
No, I think it's a good, yeah, because this is
stuff that happens.
if nothing else. Yeah, this is welcome to the wonderful world of
C++.
Not following a tutorial. Yeah.
And Microsoft.
Actually try and do something.
Okay, it looks like Can I grab this for a second? Because what I'm reading... What I'm reading is, and it sucks that you don't have a mic. I'm sorry if I'm, it's kind of frustrating not being able to talk to people. But it says that there is a thing, if you go to View, or if I go to View, whichever, I don't know if you need the mouse or if I can use the mouse because there's no communication.
Well, you could try using the mouse, and if it works, then you've probably got mouse usage.
Well, I do have usage. I just don't want to... I hate interrupting people who are trying to do something. Property manager. So here's the property manager. And again, what we have here is a hierarchy of inherited... oh, there it is. So if I right-click on this and go to properties... There we go. So here are the properties for every C++ project. So now if we jump into the C++ bit and go into the... where did you run off to? Oh, there. I already have it selected. Come in here, edit this, and move the... Well, actually, somehow these are already inherited. Who are these inherited from? I want to know. But we can remove this. This is actually a very out-of-date SDK. Do you mind if I just go ahead and nuke that from the Debugging release? Because you probably, if you want to do DirectX stuff, you should probably upgrade, unless there's another reason why.
Yeah. She did say remove. Shannon, if you could, just below the text entry box, if you could click on the drop-down and switch over to send question to staff. Your questions will start appearing in the questions panel again.
Oh, she's... Sorry, I never saw...
No, I don't normally look in that window, and then it suddenly occurred to me that that might be why.
Yeah, sorry, I didn't... So, yeah. Okay, I just didn't see that thing. Okay, so I'm going to go ahead and really quickly nuke out the SDK, and then that should fix it, and then we're done.
Cool.
All right, so that's just saying the X. Of course, that's not uninstalling anything. All that's doing is saying that C++ now will not be able to load those header files from that folder. And if you need to, again, it's the thing. So now I'm jumping into the release build, because there's two build types. There's the debug and release, and they both have different property sheets. So now by jumping into and then if definitely also just upgrade your SDK. Okay, it looks like it's not even in the release build. So now if we go ahead and do, actually I'm going to turn off really quickly. I'm going to turn off the include thing, the show includes. That's going to be under properties. Okay, so now Control-Shift-B. You should have a building project.
Woo!
Yay!
Or at least a differently not building project.
Yeah.
By George, I think we've got it.
Alrighty. So, yeah. Yeah, sorry about that. I didn't see what you were saying in the chat, and it was, yeah, kind of an interesting thing. So I'm going to jump back to me. So that's some of the fun stuff that you can do, or you can make, or can be broken by nobody's fault, really, in C++.
I'm just impressed that anyone's managed to nurture a 5-year-old SDK and still keep it alive.
Yeah.
You'd have thought at some point something Microsoft would have made it just go away.
Yeah. Well, the one thing great about Microsoft is they're usually good about compatibility until they decide to drop something.
Yeah, all or nothing.
Well, it's better than a certain company whose operating system cannot run on 3-year-old machines from that company. But anyway, okay, so what are we doing now? Are there any more questions? We did have another question. What is the function getStdHandle? Now, the getStdHandle function is a Win32 function that we use in a place. Well, I'm not used to looking at this low of a resolution now. Looks like everything is way too big. The getStdHandle is a way to uniquely identify a standard handle. And in this case, we're asking for the standard output handle. So what this code is, what this variable is it's a unique identifier that uniquely identifies our particular console window that we have open. So there's going to be two handles, or there's going to be three handles, I believe. Let me verify that really quickly. You're going to have the standard output handle, the standard input handle, and the standard error handle. All console windows have an error stream, an input stream, and an output stream. And typically the error stream simply redirects to the output stream. So what we want to do is we want to latch on into the output stream and then use the handle that we acquire from the output stream to uniquely identify which console we're trying to manipulate via the setConsoleCursorPosition function. Okay. So, are there any more questions about anything? There are different consoles. Well,
you can have. Well, it's just like with the standard command, you can show that you can open as many console windows as you like.
Yeah, well,
depending on the setup you're running, obviously.
Yeah, in C++, in Win32 stuff, the console stuff is really weird. Basically, the console was just invented primarily for backwards compatibility with DOS. And as a result, it's a very archaic API that has a lot of interesting features with it that you wouldn't even think normally possible. I do want to point out, though, that if you go through the Win32 API, this is just a fun little side note. If you go through the Win32 API, you'll notice a lot of fun stuff you can do in Windows. One of the features I wasn't even aware about until a couple of years ago is that Windows actually supports multiple desktops. As in, you can have one desktop, and then you can flip to another desktop, and then flip to another desktop, and they all have individual windows open. I found that out by going through the Win32 API and finding some functions for manipulating multiple desktops, and it's really interesting. You can find a lot of fun stuff with it. They use multiple desktops in Windows to handle the login window and the UAC window, but they don't expose it in the same way that like macOS or other Unix systems do. However, there is a tool from a company that does tie into that API to allow that to be possible.
And Wolf manages to be the winner of the first person to ask a question beginning with why award that I'm going to start handing out in every lesson. Why would we want to do that? Open more than one at a time. Well, a prime example is even, there's windows that open that you don't even think about. Blender is a good example. There's a console window in the background. And actually, even, I spent a little bit of time today playing Arkham City. And that, you can actually see the header for the minimized console window in the bottom left corner of your screen, or I can, when it's loading.
Yeah, actually, a lot of things have console windows that you can use, and it's even useful in GUI applications to fire up a console window. Although it's non-trivial. In C++, in C#, it's non-trivial, and in C++, it's non-trivial, but that's just the nature of the language. But you can actually have a GUI application and fire up a console if you want. As far as the same app, I've never fired up more than one console in the same process, and I'm not even sure if that's possible. But on the same token, you need that handle. You just need the handle. And a lot of cases where functions take in handles, like let's say you have a function in Win32 for resizing a window, if you can be all sneaky and find out the window handle of another window in another process, you can actually move around another window if you wanted to from within your own window. Win32 is not a very secure API. You can do a lot of fun stuff. You can reach into other programs and read text straight out of their Win32 components, manipulate them, hide them, show them, and stuff like that.
And Stephen said, oh, hang on. Well, Wolf, handle, this means handle in the same, in a kind of a down with the kids kind of way. It's your handle, your tag, your name. And it's literally a way of identifying uniquely the I keep wanting to say window because I'm used to dealing with C# and window handles.
Right. It is a reference. It's not a memory address. Or it could be, but thinking of it as a memory address is irrelevant, really. It's not.
It's like a nickname.
Yeah, it's just a way to do things with stuff.
Same way if, this is going to sound incredibly patronizing, but I think we all know that I can't really avoid that. It's just the way my voice works. But in the same way as if I want to identify who said something in BuzzNet, I look at their handle, their, I can't even remember what the word is for it.
Username,
nickname, username. It's that kind of handle, as opposed to door handle.
As far as the different STD output and STD input handles, the STD output handle is not the console window. It's a handle to the output stream of the console window, just as the STD input handle is the handle to the input stream of the console window. So there's a difference. A console window, so if I go ahead and fire up a console window, has an input stream, an output stream, and an error stream. And although it's still one window. And notice how I'm manipulating the input stream right now with my keyboard. And then the output stream is being manipulated by my code in response. All right, as far as getting the difference between the STD input handle, STD output handle, and STD error handle, they're all in the same console window. They're just different streams within that console window. All right, so we have about 10 minutes before break, so I think I'm going to go ahead and talk really quickly about some new features, or one new feature that we're going to be spending a little bit of time on.
New to C++ or new to
New to
us?
everybody here. Something that I can't believe that I didn't talk about before in C++ 101. And it doesn't take a long time to explain. And it's a very straightforward feature, and it's similar to features in other languages that you may or may not be familiar with. Okay, so is everybody, let's say we have a string name int age, and then we have to, of course, include string. So we have a string name and int age, and string name int age, blah, 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 name, age, blah, blah, blah. And then we have something like a string get name, return name. Okay, so everybody is more or less, hopefully,
No destructor.
well, there's nothing to destruct. Well, the string will be implicitly destructed.
Destroyed.
Okay, so I don't think anybody should have any problems with this code. This code is something that I feel that most everybody should be familiar with. What I want people to more or less be looking at right now, though, is the concept of this member and these members. What's interesting about these members, the string name and int age and the string get name? What is the constant requirement of accessing these members?
Is segfault allowed to guess?
I think he left, actually. What bit about these members make them similar in a way? Now, we have two fields, a constructor, and a method. But they all have an important aspect to them. And that is, each one of these members are instance members. That means that these members may only be accessed through the instance of an object of the type that they are a member of. So class person has these two fields, this constructor and this getName method. But the only way to access any of these members or to work on any of this code is to actually instantiate a person and access these methods through that person. So we can have two different people. So I can have a person and person 2. And both of these objects contain and encapsulate both of their fields regardless of the existence of another in isolation. But in C++ and in many other languages, there are ways... Ooh. There was an interesting question that I don't really understand. Would it be easier to name the classes in plural and instances singular? No.
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 List. If you had a list of people, a list of persons called people, that would make sense.
Sure.
But it's a person class.
Mm-hmm.
That you make a person.
Now, I don't want to say you'll never have a pluralized class name, but it's not unless the class itself is a pluralized concept. Like, let's say you had a class called Database Connections, which encapsulates multiple database connection objects, then certainly you can call that class Database Connections. But this class, its name being singular, is just born out of necessity of the fact that it's representing a singular concept. Okay, so in C++ and in many other languages, you have the ability to create members that are shared between every instance of this class. So for example, let's say I wanted to go ahead and do this. I wanted to say int, I'm going to make a public field, sue me, but this is just for demonstration. I don't know why I have the preceding thingy. Okay, what's the output to this program? Anybody? Output. Think about it. Look at it. Look closely at the code. Okay, does everybody understand why the output of this program is? Give me 1 second. Oh, great. This is going to be fun. I don't think there's any way I can actually demonstrate this without it blowing up in my face.
Okay, well, perhaps people make more sense of it the other way around, but at what point is number of people actually getting set to something?
I do want to point out that I was actually expecting the output of 1 and 1, by the way. But because of the way that initializations work, as in they don't, the output was, of course, undefined.
So that's kind of, I was expecting, so clearly I was wrong, but I was expecting what we had.
Okay, so what we have right here is we have an instance where this is an instant, this is an instance field and is owned by every object, individual object, a person that's instantiated. Okay, what's the output to this program? Look at it closely. All right, we got some 1 and 2s, we got some 1 and 1s, we got some 2 and 2s, we got some 1 and 2s. All right, let's go ahead and run this code. And in this case, we got 1 and 2.
Which is what you'd expect, which is what you'd want to get.
What's going on here? Well, there's 2 bits of syntax that I added to this code to make it behave in the way that I wanted it to. The first one is I added the static modifier to the int field called number of people. By declaring a member static, what we have essentially done is made, you can think of it like a global variable almost. We've made a member that is owned by this class, and it follows the exact same rules of accessibility and other things as far as class members go, but there's only ever going to be 1 int number of people ever, and it's going to be shared across all instances of people. In fact, I believe the static keyword in Visual Basic is actually called shared, which, to Visual Basic's credit, I kind of like that moniker a little bit more. So what we have here is a static field, and the static field is shared between all of the objects in our that are instantiated from the person type. Not only that, on line 21, we have the opportunity to initialize our static field to a value. So you'll notice that on line 21 we initialized it. This is exactly how previously, when we were using externs to define global variables, we were able to actually assign the values, our default values, to those external variables with syntax similar to this.
Would it not be possible to move line 21 inside of main then?
No, it shouldn't be. It better not be. I'll cry if it will be. I've never used that syntax before. Yeah, it's not. That syntax doesn't make any sense really, because what we're doing is the order in which this happens is a sort of that follows a lot of complex rules, and you should typically you're never really guaranteed the order of static member initialization, or you should never conceptualize your code around things behaving in a certain way. Don't you have to initialize it, or you would get an error? So if I didn't initialize my static variable, I'll get a linker error, which everybody should remember from C++ 101 when we had external variables defined in header files, and we attempted to use them in our CPP files without actually defining it. Remember the compilation process. We first have the precompiler. The precompiler does things like includes and defines and if statement, preprocessor conditionals. Then we have the compiler. The compiler takes all the CPP files, turns it into bytecode, and the compiler is very trusting. Meaning that the compiler says, well, you said there was a static int number of people somewhere. I'm just going to go ahead and hook up all the code to it in a way that makes sense. And then the compiler sends all of its translated CPP files in the form of object files to the linker. And the linker has to reconcile all the promises that you made to the compiler. And when you lied to the compiler, the linker is going to be the one to tell you off. And that's what's happening right here, where the linker is saying, well, the compiler promised me that there was this static field defined somewhere, but, well, you lied, and we can't find it. So you get a linker error saying unresolved external symbol, public static int person number of people. And then, of course, you get the mangled name right there. So in order to not have that problem, you have to actually make this exist somewhere. You have to make the integer exist somewhere. So think about it like this. This is a forward declaration of a variable, and this is the actual definition of the variable.
I'm with you, actually. I've never heard of it. It was just when you said about in Visual Basic it's called shared. That does make it a lot more conceptually obvious that it is a shared thing. Because in C#, the idea of a static class versus an instantiated class, that's one thing. But it took me ages to get my head around the idea of the fact that instantiated things could have static members and
right.
The sort of backwards and forwards of the two.
Yep, you can combine the two to whatever extent that you need. Okay, so that's a static variable, or a static field. So that's interesting. Notice something else that's interesting. Everybody in or everybody who's in C#, tell me what's interesting about line 26. Other than it's a different language. But everybody who's a C# developer and is familiar with staticness in C#, tell me what's interesting about line 26.
I know.
Because this isn't actually possible in C#, but it is in C++.
Funnily enough, the grammar freak was the one.
Well, what's going on here on line 26? Remember, this code compiles. It works. We are accessing a static member through an object, or through an instance of an object, or through an instance of a class, which is an object. It's possible to do that in C++. You can access static members through objects, which you cannot do in C#. That being said, this isn't the only way in C++ to access a static member. We could have equally have done this. So you'll notice in this case, we are not accessing the field through an object. Now there's no difference really, as far as really the compiler is concerned. But in this case, I believe that if you're accessing something that's static, you should really use this syntax. This syntax is the type that the static member is defined under, followed by the scope resolution operator, followed by the actual field that we're trying to access. or the actual member that we're trying to access, because you make static anythings.
And as Musaru said, and a few who obviously realised from the answers you were giving, this is more similar to the way you do it in C#. You refer to the type and call it on that instead of going via an instance.
Yep. Okay, 2 more things to wrap up about staticness. Well, 3 more things. Static things are not inherited. Should be fairly straightforward. Next thing, static methods. Static methods are interesting, and they behave in the exact same way that you would expect them to. So now I can say person, : static method, and I can run this code. And I get, whoa. So you can have static members, you can have static function methods, you can have static fields.
Would that static method work as well if you called it via the...
Yeah. So if I did something like person.static method, there's no difference. It's not like it really cares, but...
No, I assumed it would be that way around, but I've learned to not assume with C++.
Yes, and of course, Atomizer is giving out spoilers in BuzzNet. Okay, interesting thing is about static methods. What's the output to this program?
Well, between the red squiggly and the fact that Atomizer is saying he gets an error, I think possibly it won't work.
Oh, maybe. We might get a few...
It's just a guess.
Oh, well, we might get a few people guessing that it will work, and they'll... I mean, I'll be interested if anybody thinks this does work, what they think the output should be. Okay, so when I go ahead and run this program and hit F5, you'll notice I get a nice little compiler error. Compiler error is actually one of the more straightforward errors you will get in the C++ compiler. A legal reference to non-static member person name. That's because name is an instance field, whereas static method is a static method. You may not access static members from, or instance members from static members, although you can access static members from instance members. And,
well, to me that makes sense on the basis that, as you showed just earlier, but using the scope resolution operator syntax for it, you can set up the static. You could deal with anything static straight away. So you could deal with number of people because it's a static int. Whereas there's no guarantee that underscore name is going to exist anywhere
at all,
because you haven't necessarily instantiated a person.
Right. And furthermore, static members, like I said earlier, I think people hopefully remember this. Whenever you invoke, like getName, for example, this method, when it gets compiled, it turns into something like this. So I know that this is going to error out, obviously, because I'm using a keyword, but of course, when it gets compiled, that keyword no longer exists, but it's going to be different. It's all in assembly, obviously. But anyway, what we have here is what a method actually turns into. It gets an implicit parameter called this. However, static methods do not. Static methods do not get that an implicit parameter. Static methods are not tied to an object. Static methods may not access objects or fields or other instance members. But there is something interesting. What's the output to this program?
It's something resembling backing vocals, I should imagine.
Anybody? Output? We got one. All right, when I go ahead and run this, We get whoa whoa. The reason we get this is because static methods can actually reach into the private members of any of the objects that are of the same type that the static method is a part of. So normally you wouldn't ever be able to access the person.name the name field out of the person type because that's a private field. However, static methods may access private members of any of the objects passed into them. So that's an interesting feature of staticness. William, yes and no. That was helpful.
That wasn't an option.
Can access public members of different types? Of course. A static method may access public methods of other types. For example, I could say person.name.size. Keep in mind, size is a method on the string class, and the string class is a different type. But I can't obviously access the private members of the string class, but I can access the public members of one. Okay, any more questions about static fields, static function, static methods? Is there a reason you have person number of people equals 0 outside of main? Yes, this is not an assignment per se. It is an assignment, but it's really not. This is a special bit of syntax used for initializing static members. Now remember that an instance member is already, all of your instance methods or members, all of your instance fields are initialized on object creation. But static members must be initialized somewhere else. Obviously, the number of people field needs to be initialized regardless of whether or not you ever create a person. Meaning we have to define the initialization of this field external to both the class and to any other executable code. Can a static method access a static method that accesses the public method of instantiation that accesses a static method? It's a static method.
That was Musaru. He's just being silly.
No, I'm going to answer that question. Can a static method access a static method? Well, a static method may access a static method, yes. That accesses the public method. Static methods may access public methods of instantiated classes. And indeed. So if I had a static method that invoked a static method that invoked a public method on an object, and that public method on an object accessed a static field, that would work. Because at the end of the day, you can access static fields from within instance methods. It's a good idea. It depends on what you're trying to actually do. I don't get how you made it so static method could use name. I provided a parameter to the static method. I gave the static method a parameter of an object called person. And then I accessed the person's name. I can't access name directly because there is no object associated with the invocation of a static method. Anyway, I do need to move on. So the next thing we're going to talk about is two more instances where you will see, but did that instance it? No. Notice how I instantiated a person on line 30? And then I passed the instantiated person object into the static method. So by adding a parameter to the static method, I didn't instantiate anything, but I did so later down the road. Okay, so I'm going to go ahead and nuke all this code, and we're going to talk about static in two other contexts. The one other context that you might see the keyword static is something that we discussed in length in 101. So I'm not going to really go over it, but I will do a brief rundown of it. When you create a static void bleh, this is the old C way of defining an anonymous method or an anonymous function that cannot be accessed from any of the other modules within your project. So it's a way of using the anonymous namespace, or it's a feature that was replaced by C++'s anonymous namespaces. If you need any more information on that, look at the class where we went over namespaces in 101. All right, so let's do something fun. Let's do something with static that you can't do in C#. I'll just do it 3 times. All right, output to this program, go. William, yes, ble would only be accessible in main.cpp if it was a static method. And when I say static function, when I say static function, I'm referring to a function that's outside of a class definition. Static method has a completely different meaning, even though the syntax looks very similar. All right, so I'm going to go ahead and run this program, and what do we get? We get 111. We get 111 because every time we invoke this function, we initialize a new local variable on the stack frame, and we initialize that variable to 0. We increment that variable, then immediately print it out, which means we are going to get 3 ones printed to our output stream. By adding a single keyword to one place in this program, how would I make the output to this program turn into 1, 2, 3? Can anybody guess? Yeah, it's pretty much a dead giveaway at this point, but I just wanted people to think about it for a second. Local variables in C++ may be static. What does that mean? Well, they behave really just like static members of a class. Because I made this integer static inside of whoa, now whenever I invoke whoa, that object, that value is shared between every invocation.
So why did they choose not to allow that in C#?
Because I could foresee this causing so much confusion, especially with multi-threaded coding.
Yeah, but to disallow it altogether.
Well, keep in mind though, in C#, to get the same behavior, you could just make a static int field outside in the class definition of whoa. You know what I mean?
Yeah. Yeah.
So I just think it's one of those cases where it just wasn't. Either one of two things: either this feature has caused lots of confusion in the past, which I'm sure it has, or they decided that the benefit of adding this syntax wasn't worth the fact that you could do similar things very easily.
It's just bloat, really. If you can do it the other way.
Right.
Fair enough. I just wondered.
Yeah, it is an interesting feature. I don't know if I would ever use it. I don't think I've ever used it, but it is a very interesting feature. So, fun stuff. So why doesn't the int get redeclared and initialized every time line 7 is executed? Well, that's because line 7 doesn't get executed every time. If I go ahead and break into this, hit F5, I don't know if the debugger is going to show this or not. So let's go on an adventure. When I hit F11, notice how it skipped line 7. So that's exactly what I was looking for. Let's show that again. So now I'm on line 6 with the debugger. When I hit F11, I jump down to line 8. What we can go ahead and do, right before we go on break, I'm going to do something fun for everyone. Okay, so I made this little class called Outputter. When it's instantiated, it prints out a label, and it's when it's destructed, it prints out the label. So let's go ahead and use our little
Does it matter that you've got an underscore on line 20 that isn't there on line 14?
It's irrelevant. Well, I mean, I generally do this out of consistency reasons, but the label parameter will be the same thing as the label field because they're copied to each other.
Yeah, it's just
yeah, as a style thing, I prefer to only use fields unless I don't have a field that corresponds to that parameter. Okay, so let's go do something fun. The outputter, I'm going to use this to show you guys when things happen. Hold on. I failed at doing something really fast. Oh, right, never mind. Derp. Oh, give me a sec. I love C++ stack traces. Every day when I wake up, I'm like, yes, will I be able to look at a C++ stack trace today? Oh, well, that's fine. That's because the output stream is being uninitialized before it has a chance to work. So I don't really care about that. Let me go ahead and remove this cout count stuff, and I'm going to run this again. Okay. So, what do we see here? What we have here is how these objects are being worked with. Notice how we get an outputter out main. So main gets printed out when main starts. Then we have a, of course, I didn't actually denote this as an instance, as a destruction. Then notice this. Immediately after we invoke woe for the first time, our static variable gets initialized. And then, for every time we invoke the woe method, or the woe function, our instance local variable gets initialized and deinitialized. Notice how the destructor for static never gets hit. It will get hit at the end of the program. But of course, at the end of the program, the console window is going to close, and I'm not going to be able to see the output anyway. But what we have here is sort of the sort of proof of how the object's lifetimes are being handled. So main gets invoked. The static local variable gets initialized the first time woe is invoked, and then it sticks around every time we invoke the woe method or the woe function. Although, notice how when I have the instance on line 34, which is just a normal local variable, or local object, what we have is these being constructed and destructed at the beginning and end of every invocation of woe. So does that sort of clear up how the lifetime of static local variables work? Anybody have any questions about static local variables? All right. What I'm going to go ahead and do is I'm going to... it didn't crash that time. I'm going to go ahead and pause the video. And we're back. So let's go ahead and talk about Const. In C++, one of the interesting concepts that the developer, and it's funny because there's a lot of really, really interesting concepts about C++, like sending in parameters into the new operator or overloading the new operator for specific objects, and copy constructors and move constructors as of C++ 11. And there's a lot of really interesting concepts within the language, and one of the interesting concepts that they played with and they got working pretty well is the idea of const correctness, which from this point on I will be referring to as constness because I like saying that word. Constness is the idea that you can have an object in the context of a mutable object or in the context of a constant object. Now, let's just start off with some basic examples of what const means in some contexts, because I want to point out, just like every other thing in C++, including the keyword static and the different symbols, the word const is very, very contextual. And it can mean completely different things depending on where you see the keyword and what other things are surrounding that keyword. So if I go ahead and say class person, and I say const int age or something like that, now a person who is familiar with C# will look at this and go, well, they won't really know what's going on, because this has a completely different meaning than the corresponding C# concept of what the const keyword actually does. So that's the first thing I want to point out. So what does this code do? Well, the const in this context is similar to the read-only concept in C#, meaning that this is not a constant that's shared between all people. Now, you can have static constant fields, which behave like constant fields in C#. Const on its own, however, applied to a field, will make that field read-only. And when I say read-only, that means...
It doesn't mean that you can only read it.
Yeah, it...
Don't even get me started on that one. That just bugs me.
In much the same way, with constness, what we have here is a const field. And notice how line 12 becomes an error because I'm no longer using the initialization list. So if I try to build this, I get an error. I actually get two errors. The first error I get is that in my initialization list, I never actually set age to anything. Const fields may only be assigned to in initialization lists, in much the same way that references may only be assigned to in initialization lists. In fact, to make this easier for people to sort of understand, think about a reference as simply a constant pointer. And we'll get into what a constant pointer is in a few moments, because there is actually some strange differences between the two. So notice how not only do I get an error on line 10 because I do not provide an initialization for the age field, but I also get an error on line 12 because by defining the age field as constant, it cannot change during the lifetime of this object. The only time it can be set is during initialization. And the only time that you have the opportunity to initialize a field is in the initialization list. Which means I cannot make a void setAge function that sets age to a parameter. That is impossible. What I mean by initialization list is this. This bit of syntax is the initialization list. And we did talk about that last week, I believe, or the week before. I can't remember.
Yeah, funny enough, I was just going to ask you whether it was last week or the week before. I can't remember either. I think it was last week. Somebody will know.
Okay, so this is different than C#'s constant so far, because in C#, when you declare a field as constant, what that means is that's closer to a C++ defined. A constant in C++ is, as a field, is always going to be static. So in C#, what that means is there will only ever be one int age, shared between all people, and it can only be assigned to in its initialization, which of course you can't do in C++ because there are no field initializers. Well, there are, but there's a lot of rules and things that is associated with that syntax. So in this case, what we have is a constant int. And that constant int may only be assigned to during the initialization list and may never be reassigned. Notice how I get an error. And here's an example of an error that's more true to C++'s general errors. And this one says...
It tells you the result of the error, but not the error. Yeah.
It says expression must be a modifiable L value, or left value. Now, the age field is not a modifiable L value because it is constant. So is everybody good with this so far? You can have constant fields. They must be initialized in the initialization list, and they may never be set. They are equivalent to the read-only concept in C#. When you make a person, does each person have to create a space for int, or is there already really just one? No. This is just a normal field. This is a normal field with 2 rules. All the const modifier did was add 2 rules to this field. Otherwise, it behaves exactly the same. Those 2 rules are, again, it can only be assigned to in the initialization list of a constructor, and in fact, it must be assigned in the initialization list of a constructor, and it may never be reassigned.
C++ club.
C++ club?
The first rule of constants.
Yes. So it's kind of a waste of space then, right? No, not at all. Because it's not. It's a value. It's a value that can be changed between instances. Look at this code down here in main. I have 2 people. Each one has a different age. It is not a waste of memory because, well, it is memory that we use for actually computing results of things.
Remember, this isn't static. It's constant. It's each person's age is constant.
Right. Okay, so now that we've had a little bit of discussion about const, because there are a lot more things to talk about with const, hopefully people will understand why I kind of put off this discussion until we had a nice block of time. Let's talk about what const correctness actually sort of means. Const correctness is sort of an idea. It's a sort of conceptual thing where if you, as the developer of a program, make stuff constant, then it is less likely for you to introduce bugs. Let me tell you, in an imperative object-oriented language, or more appropriately, in an imperative pseudo-object-oriented language, which C++ is, the number 1 cause for bugs is when data changes and a piece of code doesn't account for the capacity for a piece of data to change, or it becomes invalid by nature of another piece of data changing. In fact, in object-oriented programming, that's where bugs come from. That's where the most difficult to track bugs come from. When things change and you don't want them to change. By adding the const modifier, we are ensuring that this can never change. If used appropriately, const correctness or constness, like I kind of like saying, can lead to more stable programs. Because if you can conceptualize your data model as primarily a constant thing, there will be fewer moving parts and fewer opportunities for failure.
It's kind of an extension of the idea of trying to avoid user input unless you absolutely have to.
Yeah.
Don't give the user any opportunity to make a mess of what you've done.
Right.
Unless you are absolutely forced to.
Can one make a const object in C++? Yes, and that will lead into the majority of this discussion. But I really want people to, I want people, now that you've seen constness, I want people to take a step back and think about what it means to be constant. Is everybody comfortable with the idea of constness potentially increasing the reliability of a program, and more importantly, the predictability of a program? You see, in functional languages, pure functional languages, you typically work with immutable data structures that may never change. You don't set variables. you use recursion, or you use different things that the language may expose to you, like monads in Haskell for user input and other things like that. Functional languages are less prone to errors because of their immutability. And immutability isn't a concept that is only applicable to functional programming. The more constness you use in a program, the more reliable your program will become. But we will see cases where constness can be really, or it can go overboard. As far as comparing C++ to other languages, I apologize for that, but on the same token, there are a lot of people here who know other languages, so I'll try to keep it down a little bit. But sometimes to make something click for somebody who knows another language is just a matter of saying, oh, this is just like this from another language.
Well, and also it does avoid confusion, because the primary confusion for me, for instance, coming from C# is the fact that const doesn't mean the same thing at all.
Yeah.
We use the same keyword in two different languages to mean two different things. So it is important to point out those differences.
In passing,
you're more likely to confuse someone who already knows another language than it's one of those areas where a blank slate is easier than having to kick old habits.
Can I initialize a const variable when I declare it? No, that doesn't make. Well, I mean, again, this actually gets into the rules of object initialization or field initialization syntax within C# or C++. You'll notice that if I try to initialize this to 10, I'll get only static const integral data members may be initialized within a class. And what that means is that only things like integers or bytes, or, well, there are no bytes, integers or characters or whatever may be initialized. Okay, so let's talk about other aspects of constness. Let's talk about const objects. Okay, so, or no, let's back up. Let's talk about const pointers, actually, because const pointers are lots of fun. Actually, I do want to step back one more time. So I took like 3 step backs, still. Let's talk about local fields really quickly, and let's talk about the order in which the const modifier can come in, because this will play an important role if you are reading other people's code. So I can go ahead and say const int blah equals 10, and I run this code, and it works. For those of you who are familiar with F#, this is like a let binding. We are saying that this local variable is assigned to 10, and it will never change. I may not do this. That is an error. However, I hope that that's fairly self-evident. You can have const local variables. But I do want to point out something about the const syntax. Const int and int const are the same thing. However, so if you see int const, it is the same as const int. But please never do this. Please always precede the integer with constant. And there's a good reason why you should follow that convention. When working with const pointers, the order does matter. Of course, this isn't going to work because I need an initializer. Let me go ahead and create an int. Let me go ahead and line these guys up. Okay, so how's everybody feeling about these 3 lines of code? Yeah. Expected a response like that. So let's break it down. This is a const int pointer. What does that mean? That means that I can, that means it is a pointer to a constant int. Or I think I actually mixed it up a little bit. What I meant to do was that and that. Okay, so what we have here is a pointer to a constant int. What that means is the pointer to const int can change. So look at this. I was able to reassign the pointer to point to a different value. However, I may not dereference the pointer and assign a value to it. That is because I cannot assign a variable to a variable that is const. This is a pointer to a constant integer, meaning the pointer itself may be mutated, but the integer that the pointer points to may not be mutated. So how's everybody feeling about const int pointer? That is a pointer to a constant int. The thing it points to is constant, but the pointer itself is not constant. Everybody good?
That makes sense.
Okay, so let's talk about this. This is a constant int pointer. The pointer itself is constant, meaning that while I can dereference the pointer and say const int pointer equals 20, the object that it's pointing to is mutable. I can mutate what it points to. But what can't I do with this constant pointer?
Move it.
I didn't catch that.
Move it?
Yeah, I cannot change this address. So I cannot say const int ptr equals at b or a. I get an error. I cannot reassign the pointer because the pointer itself is constant even though the object it points to is not constant. Furthermore, if you'll notice, if I take off the initialization on line 24, so I'm just going to cut that out, notice how now I have an error. All const local variables must be initialized. Because this is a pointer, or a constant pointer to an int, I must initialize it to an address when I declare it. Otherwise I'll get an error. So I have to initialize it to an address, and then I can never change that address. In a way, this syntax is very similar to a reference. Okay, so let's talk about the last one. What do people think about this? What can I do with this and what can't I do with this?
Polite answers on a postcard.
What?
Nothing. What can I do with this? Well,
Glue my fingers to a rock?
you can't do that with it. Yeah, you can read it. That's about it. In fact, yes.
I can dereference it. I can say cout const ptr to constant. I can dereference it. See that? I dereferenced it, and it worked. However, I cannot change the value, nor
Error.
nor can I reassign the address that the pointer is pointing to. References are these, Wolf. References are you can't reassign what it's pointing to, but you can mutate what it's pointing to. Oh, certainly.
I think
One person did ask a question though. If I do int const blah equals new int 40. So obviously I can get away with that, but I now have a memory leak. I can do that. But, of course, I can't reassign it to null at the end. So I can still delete the memory that it's pointing to, but I can't reassign it to null at the end of it. Where's that, Kev?
I was just wondering whether actually just tabulating those three combinations of keyword and then just columns of the value and the pointer, and just tabulating out what can be changed and what can't with each one, just visually, might clarify.
Right, so this, let's see. So they're simply different.
Print screen.
You what?
It's a quick print screen.
Yeah, there's your cheat sheet, by the way, at least as far as const pointers go. Do each one of these types of pointers have different names, like different things you would call them? Sure. I would call this a pointer to a constant object. I would call this a constant pointer to an object. And I would call this a constant pointer to a constant object. And you can kind of read that out loud. Const pointer. Or, sorry, const int pointer. So this is a const int pointer, which means that it's a pointer to a constant int. This, however, is an int pointer constant, meaning the bit that's constant is this aspect. The pointer part is constant. And then finally with this, we have a const int, so the int is constant, as well as the pointer type is constant.
And actually, yes, it really ought to have changed your variable names in your comments, but never mind.
Derp.
Cool.
Okay, so how's everybody feeling about constant pointers?
Because I'm guessing we're heading towards one of the things you've included.
I don't.
Literally at the top of the CPP file. In that meaning of it. Strings.
Oh, right. Well, yeah. I actually kind of want to talk about references first. I'm sort of restructuring this on the fly to sort of lead into that. Alrighty. So let's talk about constant references. Remember, there are only two ways that fit into this model that can be worked with references. This is what a normal reference behaves like. A normal reference behaves like a constant pointer to a non-constant object. But we can make we can make constant references. So I can say const myref, or wow, what am I doing? Const int reference myref equals a. So what is this? Can anybody tell me what this is? And can anybody tell me what I can and can't do with this? This is a constant reference. Yep, I can't change the reference because, well, it's a reference and you can't change references of references. And I can't change the value because I'm referencing a constant int. So, let's talk about constant objects now.
Sorry, you do what? You're referencing a constant int?
Yes. Is that not what that says?
Is a constant.
No. Oh, right. There's an implicit... Okay, actually, that's a good point. I'm going to back up right now. There's an implicit conversion between all non-constant things to constant things. So I can implicitly convert any non-constant value to a constant value. However, I may not implicitly convert a non-constant to a constant, or whichever way that works.
The other way.
So,
constant to non-constant.
Right. So if I go ahead and say int my int equals... Actually, what's going to happen here is kind of interesting. We're going to get a copy operation at this point. But I couldn't do int pointer, my int equals constant pointer to constant, obviously. Nor could I... Actually, well, the difficulty with this is because of the way ints work. Here we go. Or, well, that's just being lame because of that. And again, we're going to get a copy operation right here. So what's happening here is we're copying the value out of this constant pointer into a non-constant.
Which makes sense that that's fine because, well, you're just reading it as far as it's concerned. Like you said, you're copying it into another thing.
Right. In your example, const int pointer to a const int, the integer cannot be changed by dereferencing the pointer because the integer is constant. But the integer can be changed by referring to the integer directly. So why wouldn't you just make the integer constant in the first place? This is not a practical example of the use of const. I just want to point this out. I just wanted to go through the different bits of syntax of const. Here is a more appropriate example. Let's talk about strings. Actually, let's do that. Okay, I'm going to go ahead and take this code and I'm going to cut it and paste it somewhere else on my screen. If people want me to refer back to it, I'll have it handy, but I will be not talking about it anymore. Come up, Notepad. Oh, there you are. Nope.
I did actually, given that I told them all to print screen it.
Yeah.
They should have their own copy.
Okay, can anybody tell me... Give me 2 problems with this function, everybody. I want 2 problems. This function has 2 problems. Actually, let's...
Spelling? Actually, no, you spelled everything correctly.
Let's back up one more way. Actually, I'm taking a lot of backpedaling quite a bit today. Give me 1 problem with this function.
It's missing an ampersand.
Well, yeah, but why? No, yeah, I know it doesn't return a value. Okay. There.
Die roll.
Yep. The problem with this function is it copies the string, and strings can be potentially very large. We don't want to do this. We almost never want to create a function that takes in just a naked string because it'll just perform a bunch of copying operations. So, now that we have that out of the way, this is our next iteration of getInt that actually has a string reference prompt. There's 2 problems with this code. 2 problems. Go. Okay, 1 person got 1 problem. There's one more non-obvious problem with this code that I'm kind of being a little bit... I mean...
It's not const?
Well, obviously, but still, there's another true problem with this. It has to do with something that people might not be aware of, and I'm just wondering if anybody would be aware of this.
Is it what K73 said? About 5 lines up.
Not ref itself, I don't know what that means.
4 lines up.
Test if null.
Oh.
It can't be null. References cannot be null.
No, the not refer to itself. I think is what it means. That's how I read it.
Well, one person got one right. I can change the value of prompt within getInt. That's undesirable behavior. But can anybody give me a call site that looks? That's the first problem. I was talking about Craig, unless you said it too, or if that's what you meant. Can anybody give me one call site? So write out an invocation of this function that should work, but will cause an error, and it has to do with the way strings work in C++. You should be able to work this out logically. Hopefully, maybe. I mean, I am being a little bit mean right now, but come on, you guys gotta wake up. Oh. And we have a winner. Okay. Oh, well, derp. Let me get rid of the one that'll actually work. So we'll look at the one that doesn't work. Craig got it. The two problems with this function is that, first of all, we can change the value of this parameter inside the function, which could lead to undesirable behavior. Second problem, we may not pass literal strings into it. That's because literal strings, when converted into strings, or that's because there is no conversion between literal strings and string references. That doesn't make any sense. I mean, seriously, does this make any sense?
No, because it's not a string. It's
a character pointer. More specifically, this isn't just a character pointer. This is a const character pointer. There is no conversion between a const character pointer and a string reference. And that makes sense because that conversion is nonsensical. But there is a conversion between a const character pointer and a const string reference. Which makes a little bit more sense. This is the first example of a constant object. And constant objects are a very big, interesting topic about constness, which is one of the reasons why, again, I've been kind of leaving this discussion off until, a point where we can have some time discussing it. So does everybody sort of understand why we cannot convert a const character pointer into a non-constant string reference? There's no conversion for that.
I think the general feeling is no.
Well, a const character pointer this code works. Is everybody happy about this code working and this code not working? Or, well, it does work, sadly. That's a point of annoyance that I have with this language. But anyway, the point is character literals are constant character pointers or get converted into them. Even if there are some weird conversions in certain cases that shouldn't be possible, but still, regardless. What we have here is a const character pointer to a, const character pointer. which means that I cannot reach in and modify any of the values within it, which is appropriate. Because if you recall from 101, we discussed how character or string literals actually get placed into the image of their executable and loaded into memory, into the string table. And modifying that memory could have severe impact on the correctness of the rest of your program. I mean, that operation in itself is nonsensical because you are reaching into bits of your program that you really shouldn't be reaching into bits of your program for. So all character literals are going to be constant character pointers. Now we can do this. The reason we can do this is because a string has an implicit conversion from a const character pointer. You can go from a const character pointer to a string. Here's why. The string will simply copy everything that was passed from the const character pointer into its own bit of memory, which means that now that we've copied that data, we can now mutate it to our liking. We're not actually mutating the data that was made available to us on the string table, because obviously we can't do that. That would probably cause a null access violation, depending on the operating system. But we can assign a non-const reference or a character constant to a string, because what we'll get is a copy. The string will actually jump into the string table, copy all this data into itself, and allow us to mutate it in any way that we see fit. Is everybody at least good with this bit? That you can go from...
And presumably line 28, whoa, has, 4 elements?
Yes.
Because it has one for the...
Yeah, for the null terminator.
For the null terminator. So literally, because that's the thing, I mean, the string literal, although it only, it's represented with hey there, H-E-Y, there is that extra character there oh, can you try and explain what I'm trying to explain?
Yeah, stuff and things.
Yeah.
Okay. However, we cannot do this. And the C++ will tell us, cannot convert from const character pointer. Now remember, an array is really just a pointer, so when you see const character array of 4 elements, that's really just a const character pointer, to std string reference. Is there anything that could possibly make sense for us to... Is there any situation where this code makes any sense whatsoever? We're trying to take a pointer, an address to something, and turn it into a reference to something of a different type. It doesn't make any sense.
At the very least, people can see now why that frustrating thing of, well, why can't I, what's so complicated about constants? This is why we're covering this halfway through 102 and not at the beginning of 101 like we did in C#.
This doesn't make any sense because it just doesn't. Because we don't want to be able to be able to mutate our value from our string table. But if I add the const modifier to it, stuff starts making a little bit more sense. But you'll notice an interesting aspect to this. When I added the const modifier, line 27 starts to compile. That's because it makes sense to point to or have a reference to a string from a const character pointer. But it doesn't make sense, and in fact it's impossible for us to do any operations that in any way mutate that data. A const object follows a lot of very complicated rules as to what you can and cannot do with them, and we'll get into that in a second.
But just going by what you said earlier, that makes perfect sense that line 28 now doesn't work because, well, you made it constant, so
Right.
You've locked it down.
Yep, and but like I said before, the mechanism in which it gets locked down is actually part that people are going to have to understand. But conceptually that's exactly what's happening. We're locking down the object to only be constant. So I don't want to spend too much more time on this. Basically, if you want to assign a character literal to a string reference, that string reference must be constant. By making this a constant string reference, we have fixed two problems with our code. But remember, okay, so I hope everybody's good with this. If you want to pass around strings in C++, this is the absolute preferred way to do it. Const string references is how you should pass strings around in C++. From people coming from C#, this should be a very straightforward concept, because in C#, all strings they're not constant because C# doesn't have the concept of const correctness, but they are immutable. There's no way to modify a string in C#. So this should be a fairly familiar thing. And like Atomizer says, this goes for most everything. If you can get away with passing around a const reference to something in C++ for parameters, you should do so.
How much more were you intending to cover today, time-wise?
Well,
just out of interest, I'm wondering whether there's enough still to come to warrant having another break.
I kind of just want to clear up const methods, and then when we get back from break, I'll talk about const casting, const iterators, and constant method overloading.
Okay, so yes, we will be having another break.
And then there's a little bit more code that we're going to have to go ahead and write. Actually, I might leave iterators and method overloading till next week and just talking about and casting. We'll just talk about const methods right now, and then we'll go on break, and we'll come back and write some code. So, const methods. Yeah. Let's talk about objects. So as everybody knows, you can have classes, and you can instantiate objects from classes. However, every object can be in one of two contexts. It can be either const or not const. So if I went ahead and did this, what is the output to this program? Can everybody guess? Oh, people are starting to catch on. See, it's surprising because the first time I did this, actually, this is the first time people have actually started to catch on to this, where I copy code into Notepad. It's the first time I noticed, and I was surprised earlier when people actually, said it wouldn't cause an error. So, okay, well, I'll stop. You know what? I'm just going to turn off like IntelliSense or something with, or the automatic error detection in my Visual Studio. But can anybody guess why is this an error? I think Craig's an existing C++ programmer.
It's possible.
This is an error because the getAge method is not constant. Now, to people who are completely new to the idea of const correctness may be surprised to hear that you can have methods defined as being constant by adding the const keyword after the parentheses but before the curlies. When working with an object in the const context, you may only invoke methods that are declared as constant. Methods that are declared as constant may only invoke other methods that are declared as constant, and may not mutate anything on the object itself. So for example, if I had another int here called int woe, and I wanted this integer to, I'm going to go ahead and initialize woe to 0, and I wanted this integer to increment every time I invoked getAge for some reason, I get an error. Const methods may not mutate anything. They're constant. But that means that a const method is safe to be invocable when accessing an object through a const context. Is everybody good with that concept? Now, it gets very, very confusing.
Really?
But you should really do this. Anything that you can make const, make const. Exactly. Constness is particularly good for threading because immutability in general is a great thing for multi-threading.
Well, yes, and it's because obviously, yeah, I mean, presumably, is there an analogous thing to lock?
No.
Well,
you
can
the
same idea.
Get away, you can muck around with some fancy C++ syntax to make stuff look like lock, though. Oh, there is in C++ 11? Huh. So since you declared P1 as const, after the const, nothing will ever change with its state unless it cast. Yeah. Nothing invoked from getAge can change any state of person, with one exception. Of course there's an exception. There's always an exception. The last keyword I want to introduce to everybody today is mutable. A mutable field is, not surprisingly, a field that can be mutated inside const methods.
So it's kind of mutable is to const as protected is to private. Almost. Yeah, or not? Sort of conceptually, it's that halfway house.
Yeah. Yeah, it's just saying that no matter what context we're working with as object in, we can change this data. Yay for friends. Okay, so I'm not going to go down the rabbit hole too much further with const, or const methods specifically. But const methods have a lot of rules. The rules can be boiled down to something very, very straightforward. You cannot mutate anything that isn't mutable. And that's it.
That's not so much a rule as a...
Well, it's a statement.
Tautology.
I mean, yeah, just keep that in mind. You will run into situations where things get complicated. And we'll talk more next week about const casting and dealing with STL constness, as well as const method overloading. Because we're just about out of time today. Okay.
I think people's brains are just about on the edge of explosion as well. I get that feeling.
Well, we got a lot of fun stuff covered today. I'm going to go ahead and pause the... You're back. Let's talk about some code. I just want to go ahead and get a few things working. And that's it. It's not going to be very complex. The modifications we're going to make to the code is simply going to be to facilitate the ability for a simulation to actually happen in our game. And what do I mean by that? I want every entity to have the opportunity to update itself. So the first step is in the entity interface, I'm going to add a new method called virtual void update equals 0. By doing that, I'm going to have to jump all the way into main and jump into my basic entity, which I'm using for my player. And I'm going to have to add a virtual void update definition. That's because, obviously, our basic entity class implements iEntity. And by adding a new abstract member to iEntity to make this object in this class instantiatable, we have to include a definition of this function or this method. Okay, the next bit we're going to do is I want to add a method to my level called update, which is simply going to loop through all the entities and update them. Should be pretty self-explanatory. So I'm going to add the definition of update to the level class, then jump into the level class definition and add it here. So now I'm going to simply say void level update. I'm going to loop through every entity. So for auto I equals entities dot begin, I does not equal entities end I plus plus. Then I'm simply going to say dereference I, or use the dereferencing operator, of course, and do update. So that's all I'm doing, is I'm looping through all the entities and invoking their update method. But how do we call this? As of right now, our main game loop is blocking on the getCharacter function invocation inside the while loop. So we're going to have to slightly refactor this game loop to facilitate simulation. So what I'm going to do is I'm going to set input by default to equal the null terminator. Then I'm going to change the while loop to while true. Or sorry, I'm going to change the while loop to while input does not equal 27 for the escape key sequence. Then I'm going to wrap all of our input handling code into an if statement. I'm going to say if keyboard hit, or kbhit, which is a method made available to us by conio.h, or I'm going to do underscore kbhit because, like we discussed earlier, this is a non-standard function, so I want to use the underscore definition to denote that within code. What this does is this returns true, or a true value, if the keyboard was pressed. Then I'm simply going to say input equals getCharacter. So is everybody following along so far? We now have an infinite loop that continuously runs, but our input handling code will only actually get invoked if the keyboard was hit. Yeah, level update is simply an enumeration over all of our entities and simply delegating to each one of the individual entities' update method.
Capital U? Not U, K73.
Okay, so now if I jump back into main, let's add a simulation. Well, I could do this. But can anyone tell me what the problem with this code is as it stands? No, it doesn't actually update on input. It'll actually continuously update very, very quickly. Player movement should not be an update. Player movement is handled currently by our input handling system. Remember, all this code is subject to change as more features are added. I wanted to approach this as using the simplest amount of logic possible to express what I wanted to do.
So in line 57, you're saying input is the null term.
Oh, right.
And then immediately afterwards,
I'm doing that.
You're saying while input is not equal to the null terminator.
Oh, no, this is the escape key sequence.
Oh, the escape.
Yeah.
The actual escape key.
Right.
Not, okay.
But the reason I'm defining input to something is otherwise I'll get in debug mode an exception on line 60 indicating that I'm accessing an undefined variable. Okay, so the way that I'm going to write this is I'm basically going to cheat. I want level.update to be invoked 30 times every second. To do this, we are going to have to use a method for returning the amount of milliseconds that we have. Now again, we are venturing into a Win32 specific function. And the Win32 specific function is called timeGetTime. So I'm going to go ahead and write this code out really quickly. Time get time returns the amount of milliseconds that our computer has been on, and we can use this for our calculations. So I'm going to say auto last time equals time get time. Then I'm going to say auto current elapsed equals time get time minus last time. If current elapsed is greater than 33.3, then I'm going to say last time equals time get time, and then I'm going to say level.update. 33.3 is derived by the amount of milliseconds that are going to be that pass between 30 intervals of a second.
Essentially, if you divide 1 by 30, you get 0.03333.
Right, and then if you multiply that by 1,000 to convert it into milliseconds, you'll get 33.3. That's it. We now have our update method being properly invoked 30 times a second. But we have a problem. As you'll notice, when I went to compile, I got a build error. Specifically, I got a linker error. That's because time get time is defined in a static library. Now, we're not going to be talking about static libraries just yet. There's a lot of discussions about static libraries. For now, think of it like this. A static library is pre-compiled code that we can kind of stuff into our executable during compilation. So you might be thinking, well, how do I fix this? Well, the first step is to identify where time get time comes from. And doing that is actually very straightforward. If I open up Google, copy time get time, and paste it into Google, the first result is msdn.microsoft.com, so it's obviously where we want to go. If we jump into it, this is how you would identify which static library you need for a particular function. If I scroll down, look at this, requirements. So it gives us our minimum supported client or our minimum supported server, as well as the header file. And the header file specifically is that, but it says in parentheses, include windows.h, because that will include this one as well. But then it gives us the static library that we need to reference in our code to gain access to this function. And that's winmm.lib. So I'm going to go ahead and click on this, copy it, minimize Chrome, and I'm going to jump into my project settings and reference the static library. I do that by right-clicking on the project, going to Properties, jumping into my Linker tab, going into Input, going into Additional Dependencies, editing this field, and pasting the additional library that I want referenced in my project. Now if I hit OK, and then OK, and then hit F5, you now have our code running. Now this isn't the most efficient way to do this sort of simulation.
Funnily enough, I was just looking at... Oh, sorry, I was thought... because it did take a noticeable chunk more time to have to import all the Windows multimedia.
I don't know if I...
That's what WinMM stands for, isn't it?
I don't know.
I think it is Windows Multimedia. But that's presumably quite a chunk of stuff that you're including.
Yeah, I'm stuffing quite a bit of logic in here. I'm not going to worry about release build. We'll talk about configurations at another point, because I'm kind of done talking about new concepts today, as I think not only have we lost over half the amount of people that we had originally, I think everybody who's still here is probably lost as well. And I guess we can talk about lean and mean at some point too. I'll put that on the list. Okay. So that's really it as far as the stuff that I wanted to get as far as the time simulation goes.
Do you just want to have one... Is anyone actually... does anyone need to see any of what code has been added to the game itself today?
Well, there's one more change that we're going to make.
Once you've got it all through, and if you could just go through sort of all in one go.
The last change I'm going to make is I'm going to have the move entity return a Boolean, indicating whether a successful move happened or not. By changing that to a Boolean, if I jump back into level.cpp, I can now go into my move entity definition. And instead of saying return, I can now say return false, and then return true at the end. Obviously, I'm also going to have to update the return type on the implementation as well. K7, that's the homework. All right, so here's the update. Actually, we'll do this at the end after I stop recording, because all the changes I made was I updated this code right here to support the ability of simulation. I added an update method to level. I changed the return type of move entity to return a Boolean. I updated the move entity method to appropriately return the correct Boolean, indicating success. And then I implemented the update method on level itself. And that's it.
Cool.
So, for homework, I want people to go through this code and constify everything possible. I want people to think about where it's appropriate to use constness, where you can use it, and to attempt to actually write the code using as much constness as possible. That includes constant methods, as well as attempting to use constant parameter references as much as possible.
I think you finally made Wolf's head explode.
I also want people to use const fields as much as possible as well. Question: what happens when we declare a function as const? Does it even do anything? Yes. By declaring a method as const, you can now access that method through a const object reference. All right, are there any questions about the homework? Because I'm about to stop the recording, and then we'll show some code for people who want to get caught up. Because obviously, implicitly, part of the homework is to implement the time code that I just put together in the game.
Yes, I will say this. If you haven't already submitted for last week, you don't need to make two separate submissions, one without all the comments, one with just this week's as all one homework is fine. And Nelson will himself be writing the thread for this, because my brain shut down about half an hour ago, and I want to make sure that it's starting to get complicated now, and I want to make sure that I don't put the wrong thing in there or misspell anything and generally confuse people any more than they already are.
All right, so I'm going to go ahead and
Yes,
stop the video, and we will see all you future people later. So, goodbye.